Hello viewers, welcome to the next episode of Knowledge Sharing. Before continuing, like us or like on follow our Facebook page, subscribe to our YouTube channel, comment and share video for more interesting topics. Today we are looking at this question and it's from factorization of cubic polynomials. And the question says solve for the value of n in n to the power of 3 minus 3n to the power of 2 plus 2n minus 210. So in this case, cubic polynomial is when we have the highest power of n is 3. That is cubic. So we have a solution. We are going to find the value of n in this question. But before we do that, we are going to look at one example for us to see how we can factorize this cubic polynomial. So we have example. We are given x to the power of 3 plus 3x to the power of 2 minus 4x minus 12 equals to 0. So we are going to factorize this cubic polynomial for us to see the factors or the value of x in this equation. So the method that we are going to use is factorization by grouping. So in this case, this will become x to the power of 3 plus 3x to the power of 2 minus 4 minus 12. So grouping by factorization, we group this and we also group this. So in this case, we have here x to the power of 2 is common to x to the power of 3. So we are going to factor it out. So we have x to the power of 2. If we divide x to the power of 3 by x to the power of 2, it's going to give us x. Then here we divide 3x to the power of 2 by x to the power of 2 will give us 3. So in this case, we have here 4 here is a factor of 12 and 4x. So in this case, we are going to have minus 4 into, when we divide 4x divided by minus 4 is going to give us x. So in this case, this will give us plus 3 because 12 divided by minus 12 divided by minus 4 will give us 3. So this is what we have. In this parenthesis, we have they are common. So we are going to pick one of them, or we can use the parenthesis to factor it out. So in this case, we have x plus 3. If this divided by this will give us x to the power of 2. So here, if this divided by this will give us minus 4. So this is what we have. This is equal to 0. In this case, we have this as x plus 3. Then we have into x to the power of 2 minus 2 to the power of 2, all equals to 0. So we have the first parenthesis here equals to 0. And this second one, we still have a quadratic equation here, or we have difference of 2 squares here. So for us to factor this out, this will become, so we bring down this x plus 3 into difference of 2 squares. We all know that is x plus 2, then x minus 2. So these are the value of x. So in this case, it is either the first parenthesis equals to 0, or the second parenthesis equals to 0, or the third parenthesis equals to 0. Taking one after the other, we have x plus 3 equals to 0. Therefore, x equals to minus 3 when 3 transposed into this other side. Then we take this other one, we have x plus 2 equals to 0. Then we have, therefore, we have x equals to minus 2 when 2 transposed into this other side. So in this case, we have x minus 2 equals to 0. In this case, therefore, x will be equals to 2 when minus 2 transposed into this other side. So the value of x1 is minus 3, and value of x2 is minus 2, and value of x3 is 2. So it satisfies this expression for this cubic equation. So we are going to check another method for us to see how we can solve for this given question. So we need to clean this for us to see this method, whether this method will work. So we see whether we can solve that by cleaning this. So here, from our question, we are given n to the power of 3 minus 3 n to the power of 2 plus 2n minus 210. So this is what we have. If we use the method that we use in our example, factorization by grouping. So here, when we have n to the power of 3 minus 3n to the power of 2 plus 2n minus 210, by grouping these, we can see that n to the power of 2 is common. So we have n to the power of 2 into, when we divide this by this, will give us n. Then we have minus 3. So in this case, we can see that 2 is common here. So we have plus 2. When we divide 2n minus 2 will give us n. Then we divide 210 divided by 2 is going to give us minus 105. You can see that what we have here in this parenthesis is not equal to what we have here. So this method is not working. So we are going to try another method for us to see how we can solve this equation. We'll say let f of n equals to n to the power of 3 minus 3n to the power of 2 plus 2n minus 210. The function of n will be equals to 0 when we have the value of n substituted in this equation. Before we continue, we'll look at the product, because this is the quotient and this is the product. So in this case, we are going to look at the factors of this product. What are the factors of product? So we have here 110. We divide by 2. 2 will go here 1. 2 will go here 0, 5. So in this case, 2 cannot go with try 3. 3 will go here 3. 3 will go here 5. In this case, 3 cannot go, we try 5. 5 will go here 7. And 7 will go here 0. So these are the factors of 210. We are going to try one after the other. So the factors of 210, the n will be equals to 2, 3, 5, and 7. So these are the factors of this product. So we are going to use the value of n here for us to substitute whether the equation here will give us 0. So in this case, if we have f of 3 where n equals to 3, this will give us 3 to the power of 3 minus, so substituting here 3 into 3 to the power of 2 plus 2 into 3 minus 210. So here the f of 3 will be equals to 3 to the power of 3 is 27. So we have here 3 to the power of 2 is 9. 9 times 3 is 27. So we have here plus 2 times 3 is 6 minus 210. So this one will cancel here. So we have 6 minus 210 is going to be 204. Minus 204 is not equals to 0. So in this case, the value of our n from the product or from the factors of 210, which is 2, okay, which is 3, we are using 3, which is 3, does not satisfy that equation. So now we are going to use 2. So f of 2, which is equals to, we have 2 to the power of 3 minus 3 into 2 to the power of 2 plus 2 into 2 minus 210. Let's try when n equals to 2. So in this case, we have 2 to the power of 3 is 8. Then we have 2 to the power of 2 is 4. 4 times 3, we have 12. Then plus 2 times 2, we have 4. Minus 210. So in this case, we have here, this minus 12 will give us minus 4. Minus 4 plus 4 minus 210 will give us minus 210, which is not equals to 0. So we are going to try the next one, that n equals to 5. So we have f of n, which is equals to 5, will give us, so when n equals to 5, we have 5 to the power of 3 minus 3 into 5 to the power of 2 plus 2 times 5 minus 210. Trying that, we have f of 5 will be equals to 5 times 5 is 25. 25 times 5 will give us 125 minus, we have 5 to the power of 2 is 25. 25 times 3 we have 75. Then plus 10 minus 210. In this case, f of 5 will be equals to, we have 125 minus 75 plus 10 minus 210 will give us minus 150. So minus 150 is not equal to 0. So n equals to 5 does not satisfy, is not the factor of that equation. So we are going to try 7 when n equals to 7. So we have f of 7 equals to, substituting the value of n as 7 will give us 7 to the power of 3 minus 3 into 7 to the power of 2 plus 2 into 7 minus 210. So f of 7 will be equal to 7 cubed is give us 343. then minus 7 times 7, 7 squared, which is 49. 49 times 3 give us 147. Then plus 7 times 2 will give us 14 minus 210. So therefore, f of 7 will give us, we subtract 343 minus 147 will give us 196. So we add 14 here minus 210. So in this case, 196 plus 14 is going to give us 210 minus 210. Therefore, if this cancel here, we have 0 equals to 0. So this is equals to 0. So it therefore means that f, when n equals to 7, f of 7 equals to 0 when we substitute the value of n as 7 into this equation. That means n equals to 7 is a factor, one of the factors of that equation. Therefore, we have n equals to 7. And we have here n, because 7 will be transposed into this other side, it's going to be n minus 7 equals to 0. So this is one of the factors of this equation. So in this case, we are going to use a synthetic division for us to divide from this cubic polynomial for us to see other value of n that will give us the value of n from this equation. So in that case, so we clean this, we have this, as we said that n equals to 7 is a factor of this equation, or one of the factors of this equation. Therefore, n minus 7 is what we are going to use. We say using synthetic division. So with this method, we are going to divide this by this. So this will give us something like this, n minus 7. So we have n to the power of 3 minus 3n to the power of 2 plus 2n minus 210. So here we have n to the power of 3 divided by n. This will give us n to the power of 2. So we multiply n to the power of 2 times n will give us n to the power of 3. N to the power of 2 times minus 7 will give us minus 7n to the power of 2. So we are going to subtract this. So this n to the power of 3 minus n to the power of 3 is 0. So we have n minus 3n to the power of 2 minus 7n to the power of 2 will give us 4n to the power of 2. So in this case, we need to bring down this. So we have plus 2n. So the next one, 4n to the power of 2 divided by n will give us plus 4n. 4n times n will give us 4n to the power of 2. Then 4n times minus 7 will give us minus 28n. So in this case, by subtraction, subtract this. This will cancel here, and we have 2n minus 28n will give us 30n, because 2n minus 28n will be 2n plus 28n. That will give us 30n. So here we are going to bring down 210. So you minus 210. So dividing 30n by n will give us plus 30. So multiplying 30 by n will give us 30n. So multiplying 30 by minus 7 will give us minus 210. When we subtract, you can see that this is 0, 0. Therefore, we see have it that n minus 7 is one of the factors of this. So this is what we have now. So in this case, our next equation becomes n minus 7 into n to the power of 2 plus 4n plus 30 equals to 0. So when we multiply these two parentheses, it's going to give us this. So that is what it means. So we have the first parenthesis here equals to 0, or the second parenthesis equals to 0. So for the first one, which is n minus 7 equals to 0, therefore n equals to 7. So we have gotten this. So the second one, which is n to the power of 2 plus 4n plus 30 equals to 0. So we are going to factorize this for us to see how we can see the value of n from this equation. If we try factorization method, let's see whether it will work. You can see that we have to multiply this by here. It give us 30n to the power of 2. Then we need to find two factors that when we add or subtract will give us 4n. The factors of 30 are 2, 15, 3, 5. So factors of 30 are 2, 3, 5. So 6 and 5 or 10 and 3. That will not give us 4. So what we are going to use is for us to use quadratic formula for us to find the value of n. So quadratic formula will be n equals to minus b plus or minus square root of b squared minus 4ac all over 2a. In this case, our value of a equals to 1, then our value of b equals to 4, then our value of c equals to 30. Substituting this parameter into the quadratic formula, we have n equals to minus b, which is minus 4, plus or minus square root of b squared. Our b squared is 4 to the power of 2 minus 4 times a. Our a is 1 times c, which is 30, all over 2 times 1. So in this case, our n equals to minus 4 plus or minus square root of 16. Then 16 minus, then we have 4 times 30 is going to be 120 all over 2. So we are going to move over to this other side by cleaning this. So we have here n equals to minus 4 plus or minus square root of, we have here 16 minus 120 is going to give us 104 all over 2. So in this case, okay, no, minus 104. So in this case, we have this. So this is the same thing as n equals to minus 4 plus or minus, we have root 104 times root minus 1 all over 2. We all know that root minus 1 is I, which is iota. So this will become n equals to minus 4 plus or minus root 104 I all over 2. So we can write this as minus 4 plus or minus, this is all over 2, root 104 I all over 2. So 2 cancel here 1, 2 cancel here 2. Therefore, n equals to minus 2 plus or minus root 104 I all over 2. So we have two solutions from this solution. So this will become n, we have, this one was n1, so we have n2 equals to minus 2 plus root 104 I all over 2. And we also have n3 equals to minus 2 minus root 104 I all over 2. So these are the possible value of n that we've gotten from this solution, and it all satisfies this cubic polynomial. Those are the solution of those cubic polynomial. If you like what we are doing here, follow us on our Facebook page, subscribe to our YouTube channel, comment and share our video for more interesting topics. Thank you.